Hi everyone, welcome to Recitation 5, where we'll be going over Module 6, which covers recursion, and we'll also do some Exam 2 review. So, just to give an overview of things we'll go over today, um, we'll go over why we even want to use recursion, the workflow for working through a recursion problem, tracing recursion, so kind of working through what's happening in a recursion problem. We'll revisit the call stack, which we talked about a little bit last module. Um, then we'll discuss helper methods for recursive functions, and we'll do some examples, which will also help with Exam 2 review. Okay, so Module 6 covers recursion, which is widely regarded to be the hardest module in 131. So I think it's important to make sure you fully understand kind of the base level concepts here. Some commonly asked questions that we get when we get to this module are, why do I have to learn this? I could write code just fine with loops. Why would I need to add in recursion? And then, why is this so much harder to think through? And to kind of answer some of those questions and also give motivation for why we want to be doing recursion at all, um, I think the first thing is that many tasks are much easier, more efficient, and easier to read when done recursively. So I think in some of the examples and in Studio, there are some examples where honestly a for loop is totally fine and a for loop is maybe even better. But there are some problems that um, each step really does depend on the next step, and so it's kind of like an inherently recursive problem that is best tackled and easiest to read when done with the recursion. And then next, it is important to be able to break down problems into their subproblems. Um, like with recursion or going back to methods from last week, I think this idea of breaking down problems into subproblems, and instead of doing one big for loop massive chunk of code, is just a really good skill to be able to make your code more readable and easier to modify and easier to reuse down the road. Next thing is that recursion is something that you'll need as you get further in computer science. Again, there are some problems, some things that are just kind of inherently recursive, and so it's going to be really good to know the foundations for that now. And then lastly, recursion gets easier with practice. It's a little hard to wrap your head around in the beginning, but once you get into that kind of flow and recursive headspace, I guess, then it gets a lot easier. So here's kind of our fun way to explain recursion. Um, so imagine you're in a movie theater and you are me here in the front, or I guess the back of the movie theater. So you're in this movie theater, but it's a really dark movie theater, and so you can only see the row in front of you, or I can only see the row in front of me. You are me. Um, so um, all I know is that there's one row in front of me. That's how dark this movie theater is. I can just see this row in front of me with Dorian. So I can ask Dorian, hey Dorian, how many rows in the movie theater are in front of you? But it's also really dark for Dorian to see. So he can also just see the row in front of him with Professor Shook. So he can ask Professor Shook, hi Professor Shook, how many rows are in front of you? Professor Shook is in the front, so he can see that there's no rows in front of him except for just the screen. So he can tell Dorian that. And so in this example, the recursive call in this method, I guess, would be the asking step of asking the person in front. So when I ask Dorian how many rows are in front of him, and when Dorian asks Professor Shook how many rows are in front of him, that's the recursive call. The base case in this method is when Professor Shook sees that there are no rows in front of him. That's like the base case because that's when we would want to end our recursion. There are no more recursive calls to make at that point. So then what we have here, this block of code, is kind of how we would write this method, rows in front of me. And so the base case is if the person does not have any rows in front of them, in the same way that Professor Shook didn't have any rows in front of him, then return 0. Say there's 0 rows in front of me. And then otherwise, you'd want to say, well, there's 1 plus however many rows are in front of the next person. So this might not make 100% sense yet, but let's walk through it with this same example. So when I ask Dorian how many rows are in front of him, because I can only see that row, I will know that the number of rows in front of me will be however many rows Dorian tells me are in front of him, plus 1. And that plus 1 is to account for the row that Dorian is in. So what that would look like is the rows in front of me, Abby, so with Abby as the parameter, as the person, would just be equal to 1 plus the rows in theater, Dorian, with Dorian as the person parameter for this method. Dorian, when he performs his recursive call, or the method rows in front of me, Dorian, he knows that the rows in front of him are going to be 1 plus whatever Professor Shook says. So here it looks like rows in front of me, Dorian, equals 1 plus the rows in front of me, Professor Shook. When Professor Shook makes this method call, he knows that there are no rows in front of him, so here we hit the base case, and his would return 0. So now we go backwards and work ourselves back to the beginning so that we can get our answer. We know that the rows in front of Professor Shook are 0, so he can just return 0. We know that rows in front of me, Dorian, is equal to 1 plus the rows in front of me, Professor Shook. 1 plus 0 is 1, so we know that the rows in front of me, Dorian, is equal to 1. Next, we knew that the rows in front of me, Abby, was 1 plus rows in front of me, Dorian. Because we just got from the last step that that is equal to 1, then now we know that rows in front of me, Abby, is going to be equal to 1 plus 1, so 2. So the final answer that we have for the rows that are in front of me is 2. So that's kind of the fun example to explain recursion. But to give kind of a more concrete definition here, recursion is when a method calls itself. So we use recursion when we want to break a problem into smaller subproblems and solve each of these lower level subproblems by themselves, and then work our way back up to our big main problem. So the main components of a recursive method are a base case and a recursive structure. A base case is where we stop making our recursive calls. That's how you know that you've gotten to like the lowest level of the subproblems that you're trying to solve. That's how you know that you've completed what you need to do, and you can kind of work your way back up to the problem that you're trying to solve. We recommend that you start with the base case because the process of identifying the base case can also make your recursive structure more clear of what you need to write as the actual recursive structure. So some examples of base cases for different recursive methods. So let's say you're trying to make a recursive method for finding the greatest common denominator. Then the base case would be when one of the numbers evenly divides the other. And then another example would be when the height or length is below a certain threshold. So this is going to be relevant when you guys start getting into some of the recursive methods that include the standard draw library. And the problem that you're given might say, oh, you want to draw like circles upon circles is one of the examples that I know. It might say you want to draw smaller circles until you get to a certain radius. So that is an example of a base case where the base case is related to the height or length being below a certain threshold. And then lastly, in these examples, um, you might say when you've gotten to the end of an array might be a base case. Um, so these are ones that you'll see in some of our studio problems and instead of some of our like exercise problems. So just keep these in mind as base case examples. In general, when you're writing a base case, you want to ask yourself what you're trying to achieve and how you can tell when you're done with that. Um, so when you've broken this problem down into the smallest possible subproblems, that's when you know that you'll be done and ready to kind of return back to the main problem. Um, there can be multiple potential base cases in the same method, so just choose what makes the most sense for you and just know that there can be multiple options. Once you've written the base case, you need to think about what are the next steps? What work do you need to do at each like quote unquote layer or subproblem of the recursive method? So you want to think about what is needed to be done to solve one layer, like one subproblem, and what you need to do to make the recursive calls that will solve the other subproblems. So to use our theater example, to solve the one subproblem, we added one. So that was the one plus part of our code, or our code. The second part was we made the recursive call to find the number of rows in front of the person in front of me. So that was when I said rows in front of me, Dorian. So that would be, so the first part is one plus, and then the second part is rows in front of me, Dorian. And that's how we account for solving this like layer of the subproblem and also do a piece of work to get the next subproblem or next layer of the problem. In circles upon circles, which I mentioned is one of the exercises, um, the solving one subproblem would be just drawing the circle of the like layer you're on. And then the second part to make recursive calls will be making multiple recursive calls to draw multiple smaller circles. When you make your recursive call, you want to be sure to change the arguments that you're calling the method with. So that's like the parameter that you're using when you're calling the method. So changing your arguments correctly ensures that you get closer to the base case after each recursive call. If you don't change your arguments and so to like continue to break it up into smaller subproblems, you'll never reach your base case and you'll get a stack overflow error. And a stack overflow error means that you'll have infinite recursion and it'll just go on and on until your stack, your call stack, overflows with too many things to do. So in this example we have here, this is just an example of how you'd be changing the inputs to your method call to get closer and closer to the base case. So here it's calling silly addition x minus 1, and that's what decreases that to get it closer and closer to 0 and eventually get to 0. So now we're going to get into how to trace your method to get the answer. So now we're going to get into how to trace what your recursive method is doing to see how your method gets the answer. So this is what we call the substitution method, and this is how we can like write out our recursive steps and see exactly what our recursion is doing. So step 1 is to write the original method call. So using our example from the last slide, you'd say silly addition 4. So next you want to write out what that method is returning. So silly addition 4. So next you want to write out what that method is returning. So silly addition 4 returns 4 plus silly addition 3. So it adds that 4 and then it calls silly addition with the new argument 3. Now you want to repeat the steps 1 and 2 where you're just writing out the method call and what it returns until you reach that base case. So here it's pretty simple recursive step downwards until we get to silly addition 0. And we know that silly addition 0 is the base case, and it returns 0. Once you reach that base case, then you can start substituting that result back up and work your way back up. So here you're repeating that substitution step, and finally you're getting to the original method call, and you see that 4 plus 6 is equal to 10. So then that's your answer. That's the answer to silly addition 4. Yeah, so this is what we call the substitution method, and this is what we are going to use in 131 to like write out recursion and see what's happening at each step. This isn't the only way that you can represent recursion or draw it out, but it's a really good one that we like to use, but feel free to use your own method. Okay, so now we're going to do some quick review on the call stack, but if you need more information about the call stack, make sure you watch Recitation 4, actually, it's the one before this. Recitation 4, Module 5, that goes over the call stack a little bit more in depth. But basically, a stack is a data structure, a way to store data that stores information in a last in, first out technique. So what last in, first out means is that as you add in information, it stacks it. That's why it's called stack. But when you take out information, it just takes from the top. So it doesn't take the first one you put in, it takes the last one you put in. And what we use the stack for in the context of the call stack is it allows us to keep track of recursive calls. So when we're talking about keeping track of recursive calls, we need to keep track of which methods have been called and which methods are currently executing. So to do this, we create a stack frame for each method call. So in this stack of cup illustration, a stack frame would just be one of the cups, and we place it on the call stack. So that's how you keep track, is you keep placing these method calls on the call stack. So this is an example that we're going to work through to kind of look at what the call stack, quote unquote, looks like. So this kind of empty call stack we have here on the right is the call stack before line 1. So before we've done anything. So now we're going to call sum digits 1, 2, 3. And for context, on the left we have what sum digits is doing. But yeah, we're going to call sum digits 1, 2, 3. So since we've called sum digits with 1, 2, 3 as the argument, that gets added onto the call stack. So what happens when we call sum digits is it returns x modulo 10 plus sum digits x divided by 10. So here we'll be calling sum digits again within our sum digits call. So what this is going to do is it's calling sum digits with 12 as the input, or 1, 2 as the input. So what happens when we call sum digits again? It adds another stack frame. So here, the method call that's getting added onto the stack frame is sum digits 1, 2. And then similarly, what's going to happen in sum digits 1, 2 is it's going to return 2 plus sum digits 1. So that's going to be added onto the call stack, and then sum digit 0, which is called within sum digits 1, is also going to be added onto the call stack. So this is the call stack that we'll have when we reach the base case. What happens when we reach the base case? Well, once we've executed that last frame, we pop the stack frame and we work our way backwards. Because now we know what sum digit 0 is, we can plug that back in to our sum digits 1 call and start working our way backwards, plugging numbers in. So that one we can pop off because we know the answer is 1. Here we have 2 plus 1 now, and that we can pop off. And then lastly, we have 3 plus 3, and that's how we get our answer to return. So now we return 6 as the answer to sum digits 1, 2, 3. And I'm sure you can do the addition of 1 plus 2 plus 3 in your head, but yes, that is the correct answer. So we got the correct answer. What happens though if we don't have a base case? So if we deleted these three lines of code with the if x equals 0, return 0. Our, our recursion would never end in this case. Because we'd keep calling some digit 0, we would call some digit 0 infinitely, and your recursion would never end. And this would not be helpful because you wouldn't get your value of 6 returned. So this is what's known as Stack Overflow, literally because the call stack has overflown with method calls. Um, so it's exceeded its max capacity, and there's no way for it to execute all those infinitely many method calls. So this is what happens when we never hit the base case, or when we continuously make recursive calls without a reasonable stopping point. And unfortunately, this is a very common error to run into, but at least now you know what that means when you run into a Stack Overflow error. So if you see that error, Stack Overflow, then you know that, oh shoot, I either forgot to make my base case, or my base case is never being hit, or something else is happening where um, I'm not reaching a reasonable stopping point within my recursive calls. So when you see this, you can try to draw out the recursive calls that each step is making. You want to make sure that each step is somehow getting closer to that base case condition so that you can eventually get to that base case and stop your recursion from continuing endlessly.
Hi, folks. So, for the next part of this recitation, I'll talk about why we would use helper methods. You'll notice in both Studio and Assignment 6, we ask you to use helper methods on certain problems. So, you might be asking, what's the point? Why can't I just add an extra parameter to like the recursive method whose like header I already have, right? Well, adding a parameter changes your method signature, right? This means that whenever you call that method like somewhere else, it would have an error because you'd have to like add in that parameter each time you like call that method. And so this also includes the test suite. And so you're not really allowed to edit the test suite. But if like you didn't want to have that error, you would have had to if you actually added that extra parameter. So basically the reason we make the helper methods is so we have a separate method that has the extra parameter with the additional information we need to keep track of in order to perform our recursion correctly. And, like we don't mess up the test suite or any other methods that are calling like the overall recursive method we already have. And additionally, like you're splitting things up into like some more manageable chunks. Like one method calls the needed helper method, the other actually does your recursion. And like sometimes you might put like some edge cases in like your like overall method, and then if like those edge case after those edge cases, you'd actually call the helper method. But usually you can just have the helper method do pretty most of like what you need it to do, like most of everything. All right, so here's an example of a situation in which we would need a helper method. Like, let's say we have a test suite for print pairs and we can't change the parameters that print pairs has. But we want to print all the pairs in the array. So example, if we had an array just filled with 1, 2, 3, 4, and then we want our output to be 1, 2, and then backslash n just means it's on like a new line. I don't have enough space to like put everything on its own line, but so it would be 1, 2, new line, 2, 3, new line, 3, 4. So it prints each pair on a new line with a space in between. So, and like right now, we don't really have anything in our method, but how could we approach making a helper method for this method? So, what parameters would the helper method have? And in other words, like what like data would we need to keep track of in order to like go through this whole array and print all of the pairs? Additionally, what's our base case? When do we know when we stop printing all of the pairs? And what's the recursive step? What do we do to like print like pairs and then go on to the next one? So try just thinking about this on your own. Feel free to write it down. I suggest on paper, but you can also do VS Code or something. Try to guess what this helper method might look like. And we'll do it in parts. So like I'll show you like the next slide will just be like the base case mostly of our helper method. But yeah, go ahead and write down your guesses. Um, and then I'm going to the next slide in 3, 2, 1. All right. So, or wait, we're waiting a little bit for me to show you the base case, but basically our overall idea is each recursive step, we're printing the array at like some index. So this tells you we need to keep track of an index because how else would we know where in the array we are? So the extra parameter we're going to have in our helper method is just like the index of the array we're currently at. And so each recursive step we're printing array sub-index and array sub-index plus one. And then we make a recursive call to print the rest of the pairs in the array, if there are any. All right, so hopefully that makes sense. And then, so based on that, what would be a good base case? Like well, based on index, how would we tell if we've already printed the last pair in the array? All right, I'm gonna go on. So go ahead and pause and we'll try thinking about and try writing the base case on your own. And like the base case would be in our helper method. But yeah, try writing that on your own, and then I'm gonna move on in three, two, one. All right. And so, one note, like you can see here, we always want to make a helper method's access private because no other class needs to access the helper method. Like if they wanted to print the pairs, they would just call print pairs, not like the helper method for print pairs. So it's just good practice to make the helper method private. And then you can see like the return type's the same, but like really the only difference is that we have our additional parameter index to help us keep track of where in the array we are. And so I've also provided our base case. So if array.length is less than index plus one. And the reason this is the case is so um basically let's say we just printed the last pair. Well, when we print the last pair, index would have to be array.length minus two, right? Because we'd be printing the second to last index and also the last index, which would be um array.length minus one, right? But once index is equal to array.length minus one, that means like if we tried to run the rest of our code, we'd be printing like the last index in the array, and we try to print like the index after that. But there's no index after the last index in the array, right? Like array.length is not a valid index. So we'd get an error. So that's why that's the base case, because we have to stop at the value before the last value in our array. So with this, and like there's technically other ways you could have written the base case. Like you could have written the base case so that say the base we stop making recursive calls um like after we print the last two values in the array. So like say if index plus one is equal to array dot length minus one. Um, because that and like before we return, we just print um index and index plus one. That would work. But yeah, this is just how I chose to write it because it makes more sense to me. But you can technically have like a different stopping point for your recursion in at least some cases. Um, just choose like what makes sense for you and just make sure that in your recursive calls you're always working towards that base case. And yeah, that you'll always reach that base case because otherwise we'd have a Stack Overflow error and infinite recursion. So yeah. All right. Sorry, that was a big tangent, but now we're gonna pause and think, how can we implement our idea for the recursive step? So try writing this on your own if you haven't already. And I'm gonna move on to the next slide in three, two, one. All right. So in our recursive step, we first, of course, want to actually print out the like pair, right? And so our pair will start at array sub index, and then of course we have a space. And then next we're printing the next value in the array, which is array sub index plus one. Again, that's why we stop at array dot length minus two, right? Or like array dot length minus two is the last index we actually print. And then, so after we've actually printed the pair, then we're going to go to print our next pair, right? And so still the same array, of course. And then next we're printing index plus one, so the next index um in that same array. So and then we just return because we finished all our work. I mean, technically, we're like writing return um at the bottom here is optional, But I think it's good to like get used to like writing methods. The return in the if statement is not optional though because we want our code to stop running um like when we've hit the base case, right? Because if we kept going, trying to print array sub index plus one would give us an error. So we definitely want to have the return inside this if statement in order to stop our code from continuing to execute the stuff after the if statement. All right, cool. So yeah, we finished this method, and if you want to draw this out on your own, just to make sure like you understand A, why the base case works, and B, why every recursive step works, I definitely recommend that. You can use like the substitution method to write this out pretty easily. So yeah. And then, if you've like taken some time to do the like write out how the substitution method would work, now we can think about how would we would actually call our helper method in print pairs. So how would we make it so we call this helper method to print all of the pairs in the array. So I'm gonna move on after I take a sip of water. All right, moving to the next slide now. All right, we're back in print pairs, and we've written print helper. So we just write print helper to call that method. Then in parentheses, our parameters, we just the same array. So array. Then our next parameter is zero because we want to start at the beginning of the array and then print all the pairs that come after it. So yeah, that's all we have to do. And yeah, we did it. And so, also not a bad idea to like go ahead and put this code into VS Code just to test it out. You can also like run the debugger to see like what it's doing at each recursive call. You can also see the stack at each recursive call. Definitely a helpful strategy to understanding how recursion actually works. So yeah, and if you have another idea about how to how to write this code, also go ahead and write that in VS Code and see if it does the same thing. So yeah, hopefully that helps. All right, and then here's some practice problems. I won't like read all of these off to you, because you can like see them on your screen, or we also link the slides so you can see them in the slides. I think the algae L system's a fun one. I'd recommend completing it after like Dragon in assignment 6. I mean you could technically do it before. There's no requirement, but yeah, it's pretty similar to Dragon, just a different L system. So yeah, here's just some additional things to try to get you more practice with recursion. We'll go through another example of recursion during the exam review. Speaking of which, it's exam review time. All right, so starting with module 4, and I guess for each of these modules, we're putting like what I consider the most important information in these slides. But if you have anything else that, or like if you want to get a more in-depth review of these concepts, I'd recommend looking at like our overall recursion for that module, as well as like I mean the textbook will help and like the exercises, of course, will help. But yeah, so API, it stands for Application Programming Interface, which big title, but all that means is that it allows communication between different softwares. So it lets you do cool stuff like drawing or getting input from the user without knowing exactly how it's implemented. Like you don't need to know the details of like how standard draw puts your fun shapes on the screen. You just need to know how to call the method and you're able to draw stuff. Same thing with scanner. You don't need to know how it gets input from the user. You just need to know that like when the user types something in the console, like you're able to access that information and do whatever you want with it. All right. And then standard draw specifically, like I mentioned, allows you to draw, make animations, and helps you detect whenever a user clicks or uses their keyboard, all that cool stuff. So very useful for both input and output. Additionally, you don't need to memorize really any methods for the exam. Just read the documentation. And we will provide, every semester I've TA'd, we've provided any necessary standard draw methods, like documentation, on the exam. And so you just need to know how to read the documentation, which tells you how to use each method. And in the next slide, we'll go over like how to read documentation for standard draw. And then just also something important to know, the default like standard draw window goes from X being 0 and Y being 0 at the bottom left to X being 1 and Y being 1 at the top right. So that's something I definitely remember. Um, You can change the X and Y scale. You don't need to though. So I honestly wouldn't worry about it, but if you're interested, read the documentation. I believe it's like set, the methods are literally just called set X scale and set Y scale. So yeah. All right. For this example, say I want to draw a circle with a radius of 0.15 centered at x equals 0.75 and y equals 0.25. Well, documentation says filled circle, double x, double y, and double radius. So let's break out down what this means. So filled circle is just the name of the method within the standard draw API. And then double x is the x coordinate for the center. So we know that we have to provide a double in our first parameter that represents the x coordinate. And then next parameter, double y, that represents the y coordinate for the center. So we know that we need to provide a double that is like the y coordinate we want. And of course, last but not least, double radius. We know radius is the radius of the circle that we're going to draw. So again, we know we provide another double, and we know that that double should represent the radius that we want to draw. So, how do we actually call it based on this documentation? Well, you always have to put standard draw first, so it's going to be standard draw dot, then the name of the method, filled circle, and then we put in the three doubles. So 0.75 is my x, 0.25 is my y, and 0.15 is my radius. So that's the order I put it in, and here's the fun little output I get. And like I mentioned earlier, like the bottom of the screen is where y equals 0, and so the center is like 0.25, so that's why it's closer to the bottom. And then 0 is the left of the screen for x, and so that's why the circle is closer to the right side. Cool. And then note, always put standard draw dot in front of the method name, like I just said, because it's in the standard draw API. So you have to put standard draw dot in front before you put the name of the method. And then you also never include the data types of parameters when calling the method. So like if I try to do standard draw dot filled circle double 0.75 or double 0.75, I get an error because Java knows that 0.75 is a double. I don't need to say double 0.75. Yeah. Like the reason documentation says double x, double y, double radius is just so that you know the data type it needs whenever you're calling it. Like documentation pretty much just copies and pastes the method header. And we'll get to what headers slash signatures mean in the next module when we get to the next modules part of the review. Cool. And then yeah, just a brief bit on animation. I personally, I I don't think any step we'd get like too much complicated stuff about standard draw on the exam. I can't guarantee that though. And like we might ask about animation, but yeah, usually the other two modules are the emphasis for the exam. Again, don't quote me on that, but usually I'd focus more on 5 and 6. So animation cycle. Basically, there's three steps in our animation cycle. First, we clear the previous image, which we do by calling standard draw.clear. Basically, that just means like uh, we're now going to be drawing a new image, and like it resets the screen back to white. Or if technically you can also call clear with a parameter, saying like what color you want to set the screen to, but 99% of the time we're just going to do white, so you can just do standard draw.clear. And then you draw the next image, which you're just calling whatever standard draw functions you need in order to draw like your next image slash frame. And then you want to show that next image whenever you're done with it. And that'll be standard draw.show. And then you just repeat that over and over again, usually in like an infinite loop. Because like, and the reason you do that is so you clear the previous image so that you're not just drawing right on top of it. And then, so that clear method allows you to then have like a blank screen to draw the next frame on. And then you just show the next image by calling standard draw.show. That'll display to the viewer the thing you just drew. Yeah. That's just like the basics of how the animation style cycle works. And if you want an in-depth example, go ahead and look at the module 4 recitation. And then also make sure that you call standard draw.enable double buffering before you draw anything. And that is what enables you to actually have a separate frame that you show to the user and another frame that like you're drawing what you want to show to the user next. And then when you call standard draw.show, you show the frame that you just drew to the user, and then you're able, and then like you call standard draw clear, and then you're able to draw like the new like next frame that you're gonna show to the user. And so basically what that actually looks like, if you forget to call standard draw.enable double buffering, it causes like the flashy effect when you make an animation, and I show you what that looks like in Recitation 4 as well. So like if you're drawing and like you see your thing, and then it flashes white, and then you see your drawing again, that's basically because you forgot to call enable double buffering. And what that is so clear, it resets your screen to white, right? And then so you'll see that, and you'll also see like every part of your image being drawn in real time. I mean, it goes really quickly, because computers are pretty fast. But yeah, that like the reason for that flashing is you actually see the white screen for a second, and you see all the shapes being drawn, in real time because you didn't like double buffering was what enables you to have a separate frame that you show to the user and another frame that like you're drawing and you're like getting ready to show to the user. So yeah, check out Recitation 4 if you want more info on that. All right, now we're on methods. One of my favorite modules. It's pretty cool, but we're getting to my favorite module next to Recitation. So, um, abstraction is an important term to know. Basically, what it means is that you're wrapping your code up in a method so that someone else can call it without needing to know exactly like what's code is inside your method or exactly how it works. They just need to know like what it does. And so they need to know like what inputs it takes and what it outputs and like ideally like just some summary of like what it does so that they know what they're getting into whenever they call your method. So, for example, I don't need to know exactly how math.random like generates a random number. Like, it could like however it's written. I just like I don't actually know what's inside math.random. I just know that it doesn't take any parameters and that it returns a random number between 0 and 1, excluding 1, of course. And so, why do we even use methods? What are the benefits? Well, you don't need to repeat the same code over and over again. Just write your method once, and you can call it whenever you need it. Like, let's say I have a bunch of different arrays I want to print. I could just make like one method for printing an array and call that method whenever I need to. And then it also makes your code more organized, like you're not writing like the same code over and over again. Like methods just make everything a lot more condensed. And it's also easier to understand, and like keep track of everything that's going on in your program. It's also easier to edit your code. Like say I have, I don't know, just first example in my head is like the print array method. Maybe I want to print my array with like a tab between every element instead of a space. Well, instead of like, if I wrote like a bunch of different chunks of code that all printed an array, and if I wanted to change that formatting, I'd have to like go into each time I wrote that code, and like edit how I print it. And like it's easier to like miss something or make a mistake there. But if I had a like print array method, I would only have to edit like what's in that method once, and then everywhere where I call it, it would immediately like have that update where it would like change how I printed it. So it just makes it a lot easier to edit your code. And also tying back to abstraction, like let's say like I think Java wrote math.random, like the Oracle, the people who make Java. Um and so if they change like let's say I don't know exact like within the math.random method they changed like how it generates a random number. Well, I don't even need to know that. Like I would not notice any difference whenever I call math.random like as long as the types of output stayed the same and like it still didn't need any parameters, I would not know if like the inner functionality of math.random changed. So that's one big benefit. Like let's say I found a way to like make printing my print array method more efficient somehow. Then I wouldn't need to like no one anyone calling the print array method wouldn't need to change how I call it or how they call it. Um like they wouldn't even notice any difference. And so it makes your code a lot more easier to modify without having to like change a bunch of different things everywhere else in your code. So, a bit of a long explanation, but those are just the benefits of methods. And so, here's a few slides on just like the format of a method. So, and you can also get a few more details in the methods recitation, but basically, first part, access is either private, which means the method can only be accessed within its class, or public, meaning the method can be accessed by any other class. And then until we get to module 7, this next part, static, we will always write static between access and return type. I guess just for like a preview of what we learned in module 7, like static just means that your method is associated with like your overall class. Um, I won't add any more detail because I'm not trying to confuse y'all, but yeah. Just for now, all you need to know is we always write static between access and return type. Um, and then for return type, Java needs to know exactly what type each method returns in order to make sure like your method is being used correctly. And so if like your method, but if your method doesn't need to return anything, like say if it just like prints or draws, there's no output it needs to return, return type should be void. And then if it is a void method, just like a side note, whenever you're calling that method, you have to call it on its own line. You can't put like int x equals, let's say it's like your print array method doesn't return anything. You can't like write int x equals print array because print array doesn't return anything. So Java would give you a big error for that. More on how you write a method. So name just tells Java what your method is called. So that means Java knows whenever it sees name, it knows, oh, okay, you're calling this method, and it'll go and run that method. And you can have multiple methods with the same name, and we'll talk more about that later. And then if your method doesn't need any parameters, you don't need to include param type or param name. Just leave those parentheses empty. You do still need to have those parentheses just to tell Java that it's a method, but they can be empty if you don't have any parameters. Then Java also needs to know the data type of your parameters so that they make sure that Java makes sure you're using them correctly and that like other code is calling your method with the right like parameter types. And then param name just specifies what your parameter will be called within the body of the method. But that name, param name is only used within that body of the method. All right. And then any variables, including your parameters, that are made like within the method's curly brackets, are only going to be accessible inside those curly brackets. So you can only use param name inside that method. Like you might have other variables in like a different method that happen to have the same name, but um, like they won't be connected. They'll be different variables, and like within this method, like param name only exists within this method. Um, so yeah, honestly, I like to give like all the parameter names in my variable in like my methods, just all different names just to make that clear, especially like if you're first learning CS. But yeah, just know param name only exists within the method you're writing it in. All right, and so the code inside the curly brackets is just called the method body, and all methods with a non-void return type must return a value that matches return type right up here. And in void methods, you can still write return and then just a semicolon. You can't put anything like you can't do like return X or something if your return type is void though. Because that doesn't make sense. Um, and then it's technically not required. I'd say when you're learning CS, it's a good idea to put return just so that you know, oh, okay, it's returning and it's stopping execution now. But you aren't required to put return at the end. There's some situations in like you would want it to would want to write return to note just to make sure that your code runs properly, but yeah. And then yeah, returning stops the method's execution. Very important to know that like whenever you have your return statement, your code is not going to run anything else in your method after your return statement. And then I have a couple practice questions that will help us understand what um, methods do and how to write them. So for this question, will you get an error after writing this method? Why or not? Why not? And try thinking about it on your own. Like maybe write down your answer on paper. I wouldn't like write it down in VS Code because I'll tell you that like what it gives you. I mean, if you want to see it after I show you the answer, you can also write it in VS Code and see exactly what the error looks like. But yeah, all right, just make a prediction on your own. Will you get an error after this method? All right. Yes, you would get an error. So any method with a non-void return type must return a value that matches its return type, right? So in this current example, is warm outside only returns something if the temperature is greater than 75. right? So if the temperature was less than 75, it doesn't return anything. And so you definitely get an error. So, our question, how can we fix this method? So, take a second, think about how you would make it so that no matter what is warm outside would return a value. All right, moving on in three, two, one. All right, well, answer. I kind of just said this, but make sure our method returns a Boolean no matter what. And so we just add an else statement so that it'll just return false. So no matter what, either this if statement will be true and our method returns true, otherwise it'll return false. Note that this like would not work if we had like an else if it was just an else if and else if and like we return false in the else if, then there could be a like Java wouldn't be able to tell that there's a situate that like it would look at least to Java that there's a situation in which we wouldn't like return a value. Even if it was like if temp less greater than 75.0 and else temp less than or equal to 75.0 um return false. Like logically we know that no matter what that like if we would have something return, but a lot of times your compiler, if it just sees if and else if and no trailing else, um, it'll believe that it won't necessarily return a value. So yeah, just like a side note, like you can test that out in VS Code, see if that'll like makes it make more sense, and like see if you can see the error for itself. All right, we have this method, but what could be a slightly more efficient way to write it? I have two different ways to make it more efficient that I'll show you. So think to yourself, how can we make this a little more efficient? All right, moving on in. All right, pause. I'm moving on in three, two, one. All right, here's version two. So it's just if temp greater than 75, return two. And then outside of the if statement, there's no else, but just right after the end of the if statement, we return false. So think to yourself, why does this work? Why can't I just have return false right after that if statement? Well, if temp is greater than 75, this if statement will be true, right? So within this if statement, we'll return true. That's true. That's line one, right? And then it'll stop execution, right? Whenever it returns. So it won't go to run anything outside of the if statement. Like this method just stops running if after line one, right? And so our code would only go to line two if temp is less than or equal to 75, right? Because this if statement would be false and would go down to line two and return false. And then I alluded to this earlier, but there's an even more efficient way to write this method. We don't even have to worry about any if statements. So think to yourself, how can we write this method without even using an if statement? Uh, so go ahead and pause, and I'll show the answer in three, two, one. All right. Well, here's version 3. And so all we do is just return temp greater than 75. And the reason that works is because temp greater than 75 is a Boolean condition, right? Meaning it'll result in either true or false. So, like for instance, say temp is 80. Well, then 80 greater than 75 is true. And so this would just say return true. Or if temp was 40, well, 40 greater than 75 is false, right? And so it would just return false. Like, we don't need to have that if statement. Like, this statement is honestly redundant in this case. Um, so yeah, hopefully that example makes sense. Let us know if you have any questions about it, though. And so now we're going on to what's called method overloading, which is just when we write two different methods with the same name. And it's okay for two different methods to have the same name, as long as Java can tell the difference between the two methods when other code is calling it. So, question. Will this code give us an error? Like both of these methods are in the same class, would we have an error? So it's public string add, int x, and y. We just return string.toString is just how you convert an integer, like an integer or double or some other primitive to a string. So yeah, we're just converting x and y to a string and returning that. And then in the other version, it's still public static, but now it's returning an int, and we're calling the add, and the add method takes two parameters and returns a plus b. So just adds it in different senses. All right. Oh, well, yeah. As we can see from the answer on the screen, this will give us an error because if I call add with the parameters 4 and 5, Java can't tell which method I want to use because both of these versions of add both take two integers. And it doesn't matter that like those integers have different names. Um, just because like the only the data types really matter and like determine whether like your method signature is considered the same by Java. Um so yeah, basically you can't tell the difference between add if you call add 4 5 and like can't tell which method you want to use, so Java would give you a big error for that. All right. How about this question? Would Java give us an error for this code? So both methods are labeled print 5 times. One of them takes a string, and one of them takes an int. Would this code be okay? All right, like take your guess on your own, maybe write it down, and I'll show the answer in 3, 2, 1. No, then we would not get an error because these two methods take different parameters, and Java can tell the difference between calling print 5 times with like the word like the string hi and print 5 times like the number 7 because int is very different than string. So we'd get different. So like Java can tell the difference. These are considered different methods. You won't have an error if these two methods are in the same class. All right. Next question. Would this code cause an error? And I don't include the body just because like the body doesn't really matter for this question. It's just about the parameters. So for the first version of subtract or add, I have int x, int y, and then Boolean add. And then in the second version, I have Boolean add, int x, and int y. So would I have an error for this? All right, I'll show the answer in 3, 2, 1. All right, we would not get an error for this code because the parameters data types are in a different order. So Java can tell the difference between if we called subtract or add 1, 2 true, because we know it has to be the first one because it's int Boolean. And it can tell the difference between that and subtract or add false 6, 7, because that goes Boolean int. So these methods are like sufficiently different. Java can tell the difference, and we're allowed to have that without any error. So hopefully method overloading makes sense. Let us know if you have any questions about that. All right, then just a general method writing question. Try writing this on your own, either on paper or in VS Code, and then check your work with our solution. So, question 1, write a method that determines whether an array of integers is a palindrome. Like by this, I just mean like if the first index and the last index in the array have the same value, and if like the second index and the second to last index have the same value, like etc. Just like if a word is a palindrome, like if the like the first to last and second and like last have the same value, like and etc. So if like all the values kind of match up with one value on the other side of the array. So take a second, try writing your code on your own, and I'm gonna move on to the next slide in 3, 2, 1. All right, so we have public static, and just I should use Boolean for my data type, and so it is palindrome, and it'll return true if it is a palindrome and false if it's not. And it takes an array of integers. I just call that numbers. All right, and so it starts at int I equals 0, goes through I less than numbers dot length minus divided by 2, and then I plus plus, and then it just checks if numbers sub I is not equal to numbers dot length minus I minus 1. And so if all that condition is true, it returns false. And like after the for loop has run, if it hasn't already returned false, it'll return true. So why does this actually work? Well, I have an example right here with these two arrays. So, um, the first one has like an even number of elements, and the second one has an odd number of elements. So, it's kind of similar to if you wrote like symmetrical image. This is code. It's kind of similar. Um, so this array's length is 4, right? And so 4 divided by 2 is 2, right? And so this for loop would run as long as I is less than 2. So let's see if this works. So first it would check if 0, if when I is equal to 0, it would check if 0 is not equal to so numbers dot length minus 1, well 4 or minus I. Well 4 minus I is 0 right now. So 4 minus 0 is just 4. And then we have that minus 1, so 4 minus 1 is 3. And 0, 1, 2, 3. This is the like index 3 in our array. And so 3 is the last index in our array, and we're comparing the 0th index, or um like index 0 with index 3, which is exactly what we wanted to do. How about the next iteration? We have index 1, so we'd be checking if index 1 its value is equal to it would be 4 minus 1, which is 3, minus 1, which is 2. So we'd be checking indices 1 and 2, which is exactly what we wanted to do. So yeah, the reason we're doing, like, basically the reflected index will always be like the length of the array minus like whatever index you want reflected minus 1. And then let's just confirm this is the case for the odd numbered array. So in this case, the array's length is 5. Um, and so we're trying to compare index 0 with index 4, 1 with 3, and then it doesn't really matter what in value 2 is because it's just in the middle of the array. It like let's like it doesn't that like the value of 2 doesn't change whether or not it's a palindrome because like there's nothing that matches up with it. All right. So we know that, so 5 divided by 2 in integer division, that'll be 2. So you would keep going until as long as I is less than 2. I mean, we just need to check 0 with index 4 and 1 with index 3. So that is fine. That part looks fine. And then, so we're checking index 0, so numbers sub 0. And we're checking if it's equal to, so in this case, numbers dot length is 5. 5 minus 0 is 5, of course. And then 5 minus 1 is 4. So we'd be checking index 0 to see if it isn't equal to index 4. That's exactly what we wanted to do. All right. And then same thing for index 1. We'd be checking if index 1 is equal to 5 minus 1 minus 1. That's just 3. And we wanted to check whether index 1 was equal to index 3. So that works perfectly fine. And we don't do anything with index 2. So that all looks good. And then, yeah. So the reason we return false in this if statement is because, like, if the numbers, like, if index, like, let's take the length 5 example. If the value in index 0 is not equal to the value in index 4, that means it's not a palindrome because the first value isn't equal to the last value. And so yeah, that means we need to return false. But if like this for loop goes through the whole array and it doesn't find that like the corresponding indices aren't equal, um, then we can return true at the end because we've checked every index. None of them weren't equal, so we know that it was a palindrome because we didn't find any issues. So yeah, this is a bit of a complicated question, but hopefully the explanation made sense. And if like you still want to like look through it some more, go ahead and like write this in VS Code. You can use the debugger to step through each step and just check that everything makes sense. Cool. On to the next example. I think this one's a little easier. So go ahead and write a method either on paper or like on your computer that'll take an int array. And just for ease, I'll call this first array. So that's its parameter. And then we return a double array where each value is equal to square root of the value of that same index in first array. So pause now, and then I'm going to move on to the solution in 3, 2, 1. All right, we have public static. That's pretty much always there. And then we have double array for our return type. And I just called this method array square root. You can call it whatever. And then for its parameter, it takes an integer array, and its name is first array. So first step, I have to actually make the array that I'm going to return in my last step, right? So I just do make double array result equals a new double array. And of course, it has to have the same length as first array since like each value in result is going to correspond to a value in first array, right? And then I make a for loop that iterates through for first array. And then for each value or each index and result, it's going to be equal to math dot square root and like that same value in first array. So let's say first array, it's like, I don't know, I'll be boring. 1, 2, 3, 4, right? Is what's in first array. Well, then in index 0, in first array, that's 1, right? And so result sub I will be equal to math dot square root 1, which is just 1. And then for like result sub 1, it would be equal to the square root of, well, the item in index 1 of first array is 2 in that case, so it would be equal to the square root of 2, which is like 1.41 something. I don't remember that many digits, but yeah. And et cetera, et cetera. Each like index and result would be the square root of each index in first array. So yeah. Um, and then at the very end, once we finish this for loop, we would return result. This happens to also be it's kind of an example of like parallel arrays because like each index in first array corresponds to an index in result. I mean, we probably wouldn't like use them like we usually use parallel arrays, but yeah, technically parallel arrays because the indices correspond to each other. But yeah, that's just like a simple example too. And if like you want to review how that works more in depth, I'd recommend writing it in VS Code, and like using the debugger to step through it, see how each step works. And if you had like a slightly different solution, also try and write that in VS Code to see if that works. And like based on like what VS Code gives you, you can like edit that if like you need to change a thing or two. But yeah, that is that example. All right, and then recursion. I'll make this a little bit brief because this is a recursion module. We just went over recursion, but I'm gonna show one example of the Fibonacci sequence. It's technically also an exercise for this module, but or I guess it used to be an extension, so it might be like in the extension folder of like the mod of like the extension batch 2 exercises, but yeah. So Fibonacci sequence, each Fibonacci number can be calculated by adding the previous two numbers. So like the Fibonacci number for 0 is 0, the Fibonacci number for 1 is 1. That's kind of just predefined. And then the Fibonacci number for 2, well, it's the previous number 1 plus the number before that is 0. So 1 plus 0 is 2. And like it keeps following that pattern for calculating the rest of the Fibonacci numbers. All right, so first for Fibonacci, we'll have to identify the base case, which I always recommend as the first step. So for which term in the sequence can we give a definitive value, i.e. it does not depend on any of the other terms? All right, so think about like this for a second. Like I also kind of alluded to it earlier, but what two values in this list like doesn't depend on any other values? Well, when n equals 0 and n equals 1. Like I mentioned, like n equals 0 is just defined to be 0, n equals 1 is just defined to be 1, and then when n equals 2, that the result is equal to 0 plus 1, and that gives you 1. When n equals 3, this is it's just equal to the previous value plus the value before that. 1 plus 1 is just 2, and it just keeps going like in that pattern. All right. So now that we know the base case, we're going to try and identify the recursive structure. So each number is equal to the two numbers before it. So how could I break this into a subproblem? So I'm going to give y'all a second. Think about what would be our recursive structure for this. Moving on in 3, 2, 1. All right. Well, we need the previous two numbers. And so how could we find those? Well, whenever we write our Fibonacci's method, it'll to get the previous number, we just do Fibonacci n minus 1. Then for the number before that, it's just Fibonacci n minus 2. Pretty straightforward. And we just want to add those together. So we know that we would return Fibonacci n minus 1 plus Fibonacci n minus 2. And that would be the Fibonacci number for n. So, now that we've discussed the base case and the recursive step, I strongly recommend try writing this code on your own, either on paper or like a Word doc. Um, Maybe it's like practice for the exam. Don't write it in VS Code, but you can write it in VS Code if you want. But yeah, we're gonna review the solution on on the next slide. I just think it's good to like practice writing on paper, even if you put it in VS Code later. Good practice for the exam to try writing it on paper first. But yeah, I'm gonna go over the answer in three, two, one. All right, here's our solution. As always, public static. Well, sometimes we have private, but you know what I mean. And then our return type is int, name is Fibonacci, and like our parameter is int n. So, like I talked about, the base case is if n equals 0, we return 0, and if n equals 1, we return 1. Those are just like the predefined numbers that we need in order for Fibonacci to work. And then if it's not one of our base cases, our recursive structure is that we return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Um, so go ahead. I'd try like writing out an example of how that this code works. Like see, substitution method would be tricky with this one, but if you have like some way to write out this like recursion to see how it works, and you can also call like write this in VS Code and look at the call stack to all as another way to see like exactly how this recursion works. But it's a pretty common example of recursion. All right. And then, yeah, that's all we'll do for like the exam review part of recursion because we just covered recursion in depth. But all right. So upcoming quiz 6 will be on Monday. And again, this is like the hardest unit, arguably. So I definitely prepare a lot for this quiz. And then next Wednesday's studio will be more like office hours. You'll just join the help list, and a TA will help you with any exam review or assignment or really anything 131 related questions that you may have. And then exam 2 is on Thursday, 10:30 from 6:30 to 8:30. So again, just check the exam 2 page to see what your room number is for the exam and like what you should bring to the exam. Um, and yeah, that is about it. Let us know if you have any questions as always, and thank you so much for watching. Best of luck with Module 6 and good luck preparing for the exam. Bye bye!